Hi, how you guys doing everyone? I'm Neural Patel and welcome to my first tutorial on CSCI 360. Today I'm going to be talking about decimal number system, binary number system, and hexadecimal number system. So let me begin by talking about decimal number system. So decimal number system is the generic number system that we go off of, which is 1, 2, 3, 4, ECD. The number system that we learned in kindergarten is considered a decimal number system. It is done through BATE and is a base 10 number system. This is very important because knowing decimal number system, we could really convert it to other number systems such as binary and hexadecimal. So let me try to do an hexadecimal numbers or a binary number system. So binary is done through base 2. A lot of people don't understand binary number system at all. Binary number systems are used to communicate with a computer. So most of the time when you have a good example of this is, imagine you have a bunch of data that you get in from a client. Then that data has to be communicated through a computer. How is that possible? You use a binary number system in order to communicate with the computer. So let me give you an example of binary really quick. So 1, 0, 1, 0. So binary number systems, they're also known as ones and zeros. They go off of, they start with 2 to 0, and then next one, which is this is one right here, will increase by 1 exponent each time. Will be 2 to 1, 2 to 2, and 2 to 3. So for this example right now, you see that it's 1 0 1 0, and you're like, okay, so I do 2 to 0, 2 to 1, 2 to 2, 2 to 3, and I add them up. That would not be the case. So you only add up the numbers that are ones, not zeros. So it's similar to closing a door. Imagine if you want your door to close, you put a 1. And if your door is open, you put a 0. So this is the same example. And this is, so for 1, oh man. So for this one, it's a 0, so you don't have to worry about it. But just write down 2 to the 0, just to make it easier for you to really calculate data. Plus 2 to the 1, plus 2 to the 2, plus 2 to the 3. If you look at it, 2 to the 0, you can cross that out. And the next one is 2 to the 1, which you can just keep. And then next one is 0, so you can cross out 2 to the second too. So what you'll be adding was 2 to the third plus 2 to the 1, which would equal 8 plus 1, which would equal 9. And that 9 right here is a decimal number, which is what we see in everyday world. Now you're like, okay, this is very important and all, but what does that have to do with what assembler programming is? Well, assembler programming is based off of binary and hexadecimal numbers. It does include decimal numbers as well, because we are so used to viewing decimal numbers, but the computer is not used to decimal numbers. They're used to binary numbers. And that's what I'm going to show you guys today. So the final one is hexadecimal numbers. Now in hexadecimal, it goes from 0 to 9. And then after it's done from 0 to 9, it goes from A to F. The reason why it's like this is because hexadecimal numbers are used to communicate with binary numbers. So a good example of this is 1010. So a good way you could put it, actually 10, let me cross this out and actually make it easier for me to give out my examples. So the first one is 2 to the third. Second one is 2 to the second. Third one is 2 to the first. And the last one is 2 to the 0. You don't have to worry about the 0 because 0 is a 10. So worry about these three, which is 8 plus 4 plus 2. 8 plus 4, which is 12, plus 2 is 14. Now you're wondering, okay, you got 14 down. What is that in hexadecimal? So A is 10. You could also, A is 10, B is 11, C is 12, D is 13, E is 14, and F, which I ran out of room, is 15. So you look at it, you're like, okay, E is the correct answer. Here is 14. So that in hexadecimal is E. Now this is all messy, but I'm gonna give you guys a better example. So right now I'm in CSEI 360 section 2, Harry Hutchins homepage. So right now I'm gonna go down, and there are some examples that you guys could do in extra practice. If you go down to practice work, you click here, you click more, and here are some problems that you can work off of. So I'm going to work off of a couple of problems. The most difficult problems are usually C and D. A and B seems fairly straightforward, but C and D are very difficult problems. I'm going to work with those problems with you. So let me start off with should be done. So let me start off with the binary numbers to decimal representation. Oops, these are my notes that I took. Binary number to decimal representation. So for C, we have 1, 1, 1, 0, 1, 1. Now, the way you could convert a binary number to a decimal number is through the example I showed you, which is the power, which is 2 to 0 for the first one, and it goes up a value by 2 to 1, 2 to ECT. So let me try this one. So you have 1 plus 2, and then this one's a 0, which would have been a 4. So you skip that one. Or if you want to write it, you can write 0. And then 8 plus 16 plus 32. I did math in my head. But here, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and 2 to the 5. Now you're allowed to use a calculator in this course, so don't try to do everything through your head or paper, just use a calculator. Since I can't show you my calculator, I'm just going to do on here. 2 to 5 is 32, plus 16, plus 8, plus 4. I mean, not 4. That's why. Plus 2, plus 1, which will equal 59. So for C, it'll be 59. So let me erase this. Let me do D really quick. Which is 0, 1, 0, 1. So for this one, you want to look at it, you're like, okay, so my first test, what do I do? So this is 2 to the 0, which is valid, plus 2 to the 1, which is not valid. So cross it out so you don't add it up accidentally. Plus 2 to the 2, which is valid, plus 2 to the 3, which is not valid. So the only two things that you're going to add up is 2 to the 0, which is 1, plus 2 to the 4, which is 4, 2 to the 2, which is 4, which would equal 5. And that will be the decimal representation of that number. If you guys have any comments or questions, please comment below. I'm on stream on YouTube right now, and I'm trying to teach people as well as show my school that I could do this. So let's do 2C, which is C, E, F. Now in this example right here, you had to turn a hexadecimal number to a decimal representation. So most of the time when you look at this, you're like, okay, what do I do first? Like, I don't know what to do. So here, let me give you an example. Oh wait, I didn't explain it, give me one bit. So for this one, you would look at it and you will figure out, oh, what kind of base is it? So hexadecimal is done through base 16. And you want to convert it into a base 10. How would you do that? Well, first off, just by looking at F, if you would convert F into a decimal representation, that will equal 15. So that is the one thing that you have to remember. So put 15 down. And then since this is off of base 16, you will put 16 down. And then you put a 0. The reason why you would put a 0 is similar to the binary number and decimal representation. It increases over time. It increases as the number gets bigger. So that's 15. Plus. So next one you look at it is E, which is 14 times 16. So this one is that. And our last one. So what is C? C is 12 times 16 to the second. And you would add all these together. So let me take out my handy dandy calculator and try doing it. So 16 times 16 times 12 okay. 14 times 16 and then you would add these up. Plus 224 plus 15, which will equal 3,315. Oh! And that will be the answer to 2C. Now, if you look at the second question, which is 2D, it's BA9. I think you could get the gist of this, which is get the first number, figure out what the decimal representation is. Decimal representation should go here, and times by the placement. So this is the first one. So the first placement is always 0. Second one, and then third one. So for this, for D, it'll be 9. I'll just help you out with this, but I don't really want to get this YouTube video exposed and give you all the answers because it wouldn't be great. So I'm just going to leave it as an example for 2C. So let's do 3 really quick, which is convert the following decimal numbers to their hexadecimal and binary representation. So you're like, oh, now it's a game changer. Yeah? Okay.